Congratulations on completing the first task and on remembering how to write code to generate exponential random variables. As we're going to see in the remainder of this exercise, an ability to write code that generates exponential random variables is really essential when it comes to writing programs to simulate any kind of continuous time Markov chain. For instance, in this video, you are going to learn how to simulate the most basic of these continuous time Markov chains, the poisson process, and you're going to see how an ability to generate exponential random variables is really central to writing a program to simulate this kind of chain. Before we get onto the program, however, let's first quickly remind ourselves about the transition graph for a poisson process. Remember that a poisson process simply counts the number of events that have occurred by a certain time t, given that each of the events occurs at a random time, and also given that the stochastic process is memoryless. The transition graph for this type of Markov chain is thus the one shown here. In addition, elsewhere on my website, you can find videos that take you through the process of deriving the jump rate matrix for this chain, and also for solving the associated differential equations. The net result of all this maths, however, is the expression shown at the bottom of the slide that tells us the probability that exactly n events occur during a time window of length t. Let's now consider how we might simulate a Poisson process on a computer. I have reproduced the equation for the probability that exactly n events occur during a time window of length t here. By substituting n equals 0 into this expression, we can quickly arrive at the following expression for the probability that no events will have occurred by time t. If we take 1 minus the probability that no events have occurred by time t, then we obviously get the cumulative probability distribution function for the time until the first event, which is shown at the bottom of this slide. This is the cumulative probability distribution function for an exponential random variable, however, which we already know how to generate. What we have thus established is as follows. If we want to work out the amount of time that will pass before the first event in our Poisson process, we simply have to generate an exponential random variable. It gets better still, however, as remember the Poisson process has no memory. Once the first event has occurred, therefore, we can reset our count of the number of events to 0 if we want, and we can start again. The time between the first and second events can thus also be generated by generating an exponential random variable. We can thus quickly see how to build a plot like the one shown in this graph that shows the number of events that have occurred as a function of time. We generate the time for our first event by generating an exponential random variable x1. We can then obtain the time for the second event by generating a second exponential random variable x2. The time for the second event will then be x1 plus x2. To generate the time for the third event, we generate a third exponential random variable x3. The time at which the third event occurs is then x1 plus x2 plus x3. In short, generating the times of the events for a Poisson process is really rather straightforward if you know how to generate exponential random variables. With that in mind, have a go and see if you can do the next task. Good luck.